Hello, welcome my followers. Today's topic starts from this example number 2. Suppose a substance loses half of its radioactive mass per year. If we start with 100 grams of a radioactive substance, how much is left after 10 years? Okay, let's list out here given things here. Suppose a substance loses half of its radioactive mass per year. If we start with an initial condition at 100 grams, this is initial condition. So we have given, let's say G naught is equal to 100. G naught which is equal to 100. Now what we need to find here, a radioactive substance, how much is left after 10 years? Let's compute G1 here. G1 which is equal to, suppose the substance loses half of its radioactive mass per year. So it is the half of G naught. G1 will be 100 times 1 over 2. Again let's calculate G2 which is equal to 100 times 1 over 2 to the power of 2. That means this is equal to 50. This again 100 times 1 over 2 square. 1 over 2 squared, which is equal to the half of 50 divided by 2, which is equal to 25. So 1 over 2 to the power of 2. 1 over 2 to the power of 2, 1 over 4. 100 times 1 over 4, 25. That means 50 divided by 2, which is equal to 25. Now from this we can generalize for we can compute for G10 which is equal to 100 times 1 over 2 to the power of 10, 1 over 2 power 10. This is equal to 100 over 10 to the power of 2 to the power of 10, 2 power 10 to the power of 10. This is equal to let's calculate 2 to the power of 10. Here we have 2 power 10 is equal to 1024. So this is equal to 100 over 1024. So this is equal to 100 divided by 1024. Let's calculate it. 100 divided by 0 to 4, which is equal to 0.098. This is for G10. Okay, let's we can read it here. G10 which is equal to 0.09, approximately 6 to 8 here. So 0.098 we can approximate like this. Now let's do this exercise 1.23. A certain item loses 1/10 of its value each year. If the item is worth 28,000 today, how much will it be worth 4 years from now? A certain item loses 1/10. This 1/10 means 10%. This 1/10 refers 10%. 10% here we have. Okay, we have the condition here we have. If the item is worth per initial condition, let's compute. Let's take this 28,000 as G naught. G naught which is equal to 28,000. Now what you compute? A certain item loses 1/10 of its value each year. So to calculate G1, we have rate R which is equal to 10%, and given G naught is equal to 28,000. Now let's calculate it. G4. Before computing G4, let's calculate G1. G1 which is equal to G naught minus, because it loses 10% or 1/10 of its value each year. So we can compute like this. G1 which is equal to G naught minus G1 times 10. That means 10 times 10% times G naught. This is equal to, let's take common G naught. G naught into 1 minus 10%. Again this is equal to 10% is 0.01. G naught times G naught into 1 minus 0.1, which is equal to 1 minus 0.1 is 0.9. 0.9 times G naught. This is for G1. Now let's compute for G2. G2 is equal to G1 minus 10 times of 10% times G1, which is equal to G1. Let's take common again. G1 into 1 minus 10%, which is equal to, instead of G1 let's substitute this one, G naught into 1 minus 10% times this one, 1 minus 10%. This is equal to G naught times 1 minus 10%, 1 minus 10% squared like this. This is equal to G naught product is 1 minus 10% is 1 minus 0.1, 0.9 square. 0.9 squared. Sorry, here 0. G naught. Now let's calculate what we need to find here. G4. Let's compute G4. To calculate G4, we use this formula. G4 is equal to G4, which is equal to G naught times G naught into 0.9 the power of 4. Because for G2 is equal to G1, G naught times 0.9 square. Similarly for G4, G naught times 0.9 the power of 4. So this is equal to G naught, we have 28,000 times 0.9 power 4, which is equal to so this is equal to 28,000 times 0.9 the power 4. Let's calculate here. 0.9 power 4 is equal to 0.6561. 0.6561, which is equal to, let's multiply this by 28,000 times here 28,000, which is equal to 18,370.8. 18,370.8. This is the answer for question number 1. Let's go to question number 2. A boat is now worth 34,000 and loses 12% of its value each year. What will it be worth after 5 years? Let's take this as G naught and this as rate 12%. Okay, let's do this here. This is the question number 1. Let's do question number 2. Question number 2. We have given rate R which is equal to 12%, and G naught is equal to 34,000. Now let's calculate G1. G1, which is equal to G naught minus 12% times G naught. This is equal to, let's take common G naught into 1 minus 12%. This is equal to G naught times 1 minus 0.12. 1 minus 0.12 is equal to 12% is 0.12. 1 minus 0.12, let's subtract it. 1 minus 0.12 is equal to 0.88. So it is G naught times 0.88. This is for G1. Now let's compute for G2. G2 is equal to G naught G1 minus 12% times G1. is equal to, let's take common G1 into 1 minus 12%. 1 minus percent. This is equal to, now let's substitute instead of G1 here, you can write like this: G1 into 1 minus 12% is 0.88, which is equal to, again instead of G1 let's substitute this times 0.88, which is equal to G0 times G0 product is 0.88 square, 0.88 squared. This is for G2. Similarly, what we need to find for G5, we can compute G5 using this with the same fashion. G5 is equal to G0 times G0 into 0.88 the power of 5, because for G2 here we have G0 times 0.88 squared, so for G5 G0 times 0.88 power 5, the power of 5, which is equal to, we have given G0 34,000 times 0.88 power 5, which is equal to, now let's calculate 0.88 power 5, 0.88 times 0.88 times 0.88 times 0.88 times 0.88, how many times? 1, 2, 3, 4 times 0.0 times, okay, let's compute simply. We can easily compute 0.88 power 5, 0.88 power with 5. This is equal to, let's take with 2 decimal place 0.53 times 0.53, 34,000. This is equal to 340 times 53, which is equal to 340 times 53 is equal to 18,020. This is for G5. Now let's do the next equation number 3. Equation number 3, the population of a certain town is increasing at a rate of 2.5% per year. If the population is currently 100,000, what will the population be 10 years from now? So let's take the given condition here. We have R0 point, rate R, which is equal to 2.5%, and G0 is equal to 100,000. Now here is, let's calculate G1, which is equal to, since here the population of a certain town is increasing, so we can take G1, which is equal to G0 plus G0 times times 2.5%. This is equal to, let's take common G naught, which is equal into 1 plus 2.5%, 1 plus 2.5%, which is equal to G naught into 1 plus 2.5% is 0.025. Again, this is equal to G naught times G naught into 1 plus 0.025, 1.025, which is equal to, okay, no problem, let's stop it here. Now let's calculate it for G2. G2, which is equal to G1 plus G1 times G1 times 2.5%. This is equal to, let's take common G1 here, G1 into 1 plus 2.5%. This is equal to G1 instead of G1, okay, no problem. G1 into, let's add this, 1 plus 0.025, this is equal to G1 times 1.025. This is equal to, instead of G1, let's substitute this. So this times 1.025, product here 1.025, which is equal to G naught times G naught into 1.025 square, 1.025 square. So generally from this what I understand, our aim is to find G5, G10, sorry, G10. So it is G10, which is equal to G naught times 1.025 the power of 10. Can put it like this, power of 10. This is equal to now let's substitute 100,000 in place of G naught, 100 times 1.025 the power of 10, power 10. This is equal to 1.025 power 10 is equal to, let's take into decimal place 1.28. So 1.28 times 100,000. This is equal to, let's omit it to this to 0 by shifting this decimal place to this. So 1000 times 1000. This is equal to 1000 times 128, which is equal to, so after multiplying this we get 128,000. This is the answer for question number 3. Now let's go to question number 4. Number 4 states here, Sophia deposit burst 3,500 in a bank account, paying an annual interest rate of 6%. Find the amount she has at the end of the first year. So here is the given thing. This is, let's say this is G naught. Question number 4, G naught which is equal to 3500 and rate R also given 6%. Now let's calculate it for the first year. G1 which is equal to G naught plus G naught times R, 6%. G naught times G naught product is 6%. This is equal to, let's take common G naught into 1 plus 6%. This is equal to G naught times 1 plus 0.06. Six percent is 0.06. So this is equal to G naught times 1 plus 0.06, 1.06. This is for G1. Now let's go to compute. Okay, for G1 number 4A. This is for question number 4A. So let's substitute. This is equal to G naught, we have 3500 times 1.06. This is equal to 35 times 106. This is equal to, let's multiply 35 product is 106 is equal to 3710. This is the answer for question number A. Let's go to question number B. Number B states, what you have to find for question number B, the second year. G2, let's compute it. G2 is equal to G1 plus G1 times 6%. G1 times 6%, which is equal to, let's take G1 common. G1 into 1 plus 6%. 1 plus 6%. And this is equal to G1 into 1 plus 0.06, which is equal to G1 times 1.06. This is equal to, we have G1 value here, 3710 times, sorry here, okay, no, not like this. Okay, no problem, you can use like that. 3710 times 1.06. This is equal to let's multiply 3710 times 1.06 is equal to 3932.6. This is for year 2, G2. Let's go to question number C. Number C is the third year. Let's compute G3. G3 is equal to G2 plus G2 times 6%. G2 times 6%, which is equal to again equal to G2 into 1 plus 6%, 1 plus 6%. This is equal to okay, here we can express like this one. G1 times 1.06. Instead of G1 we can use this. So this is equal to G0 times 1.06 the power of 2. For deriving the nth term formula we have to put it like this. So for G3, which is equal to, again instead of G2, okay, let's compute this. G2 times 1 plus 6% is 1.06. So this is equal to, instead of G2, let's put it this. Copy, we have V times this 1.06, which is equal to, after computing this, you get G0 into 1.06 the power 3. Here we have power 2, here we have 1, 2 plus 1, 3. Power 3, so this is equal to, let's substitute G0, 3500 times 1.06 power 3. So G3 is equal to, let's multiply this. .06 power with 3 is equal to, let's take into decimal place 1.19 times 1.19, 3500. So this is equal to, again let's multiply this. This is equal to, let's omit these two 0, 35 times 119, which is equal to 35 times 119, which is equal to 35 times 119, which is equal to 4165. 4165. This is for G3. Now let's go to question number D in the 4-0. Let's compute in the 4-0. D, what we need to find G4, which is equal to G0. We can use this formula, G0 times 1.06 the power of, we can put it like this. This is equal to, G0 is equal to 3500 times 1.06 the power of 4. Let's calculate using this calculator. 1.06, I'm sorry, 1.06 power with 4. This is equal to, let's take into decimal place 1.26. 1.26 is equal to, let's omit these two zeros, so we have 35 times 126. This is equal to, so here is 35 times 126. This is equal to 4410. 4410. This is for G4. Let's go to question number E. Question number E states we want to find Gn. So Gn is equal to G0 times 1.06 the power of n. Power n. This is the nth term formula. Let's go to the next question. F. Do the amount shares at the end of each year for a geometric sequence. Explain. So this, from this what I understand, this sequence is this geometric sequence. Question number F. Yes, it is. It is a geometric sequence. The answer will be yes. It is a geometric sequence because we have r is equal to 1.06. Common ratio r. We have common ratio r 1.06. So this represents what? Geometric sequence. This is all about exercise 1.23. Now let's go to the next example. Example 1. A man was injured in an accident at work. He received a disability grant of 4,800 ETB in the first year. This grant increases with a fixed amount each year. What is annual increases if he received a total of 143,500 ETB over 20 years? Number B. His initial annual expenditure is 2,600 ETB, which increases at a rate of 400 ETB per year. After how many years will his expenses exceed his income? So let's calculate it. This. What is annual increases? If he received a total of 143,500 ETB over 20 years. This is what? S20. This is S20. What we want to find? What is the annual increase? Common difference D. We want to find common difference D. So let's calculate it here. We have given S20 which is equal to 143,500. Now let's use the formula Sn. Here we have Sn is equal to n over 2, n divided by 2 times a1 plus an. A1 plus an. From this again, which is equal to n over 2 times we have a1 plus an, a1 plus n minus 1 times d, n minus 1 times d. This is equal to n over 2 here, a1 plus a1 twice of a1 plus n minus 1 times d, n minus 1 times d. So here let's go substitute here. Sn we have 143,500 which is equal to n over 2, n will be 20 divided by 2 times 2a1 here, 2a1 plus n minus 1 times d. What you want to find? Common difference d. So what is the value of a1? Let's see here. a1 here is, he received a disability grant of 4,800 ETB in the first year. So let's substitute here. 2 times a1, 2 times 4,800 plus n minus 1, 20 minus 1, 19 times d. This is equal to 1 143,500, which is equal to 20 divided by 10 times, what is this, 2 times 4,800, 9600 plus 2 times 19d. Again this is equal to, let's multiply by 10 here, 9600 plus 90 times 10, 190d. Now here 143,500 minus 96,000, which is equal to 1990d. Let's calculate this. One 143,500 minus 96, which is equal to 47,500. 47,500, which is equal to 190d. Let's divide both sides by 190. So d is equal to 47,500 over 190 is equal to, so let's calculate it. 47,500 divided by 190, this is equal to 250. So this is the common difference D. So we can cross check it here. Question number 8. Since the grant increases with a fixed amount each year, the problem is infinite arithmetic series and the sum is given us like this. So what is the common difference D value? Here we have 250. So we have the same answer here, 250. Now let's go to the next question. His initial amount expenditure is 2,600 ATB, which increases at a rate of 400 ATB per year. After how many years? What we want to find here, n value. His expenses exceeds his income. So let's calculate this one. So let's calculate this. His initial annual expenditure. His initial annual expenditure is, let's say this is A1. This is question number 8. Let's go to question number B. For S expenditure, expense, we have given initial A1 which is equal to 2,600. The other thing given here, which increases at a rate of common difference D. We have D is equal to 400. Now let's compute what we want to find here, n value. So let's put this. S expenses is equal to S is equal to S expenses n over S expenses. Let's represent by SE. S is equal to n over 2 into a1 plus a1 plus an, which is equal to n over 2 into a1 plus a1 plus again n minus 1 times d, n minus 1 times d. This is equal to n over 2 times a1 plus a1. Here we have 2a1, 2 times a1 plus n minus 1 times d, n minus 1 times d. After this, let's substitute given condition. SE is equal to, we don't know any value, we put it as it is, n over 2 like this, times 2 times a1, 2 times 2600, 2 times 2600 plus n minus 1 times d, n minus 1 times d. We have given d 400, so we use 400. Now this is equal to, we can put it like this, SE, expenses is equal to n over 2 into, let's multiply this, 26 times 2, 52,000 plus 400 n minus 400. This is equal to n over 2 into, let's subtract from 52,400, let's subtract it, 52,500 5,200 minus 400, which is equal to 4,800. 4,800 plus 400 in 400 n, which is equal to, like this, let's write it, 5,200 plus 400 n minus 400, which is equal to n over 2. Now let's divide each term by 2. This divided by 2, n into 2,400 plus 400 divided by 200 n. Now SE is equal to, let's multiply this. This can be right, distribute n 200 n square, 200 n square plus this, distribute it 2,400 n. Now the other thing, let's find for S income. S income can be expressed, S income is equal to, let's express SI. We have given for ASI A1, we have given A1 is equal to 4,800 and common difference D is equal to 250. We already have got it here, so let's substitute here. SI is equal to SI, which is equal to n over 2. What we need to find will be n over 2 times A1 plus AN, which is equal to n over 2 times A1, here is A1 plus AN, A1 plus n minus 1 times D, n minus equal to n over 2 product is a1 plus a1 twice of a1 plus n minus 1 times d. N minus 1 times d. So here is SI, which is equal to n over 2 into 2 times a1 will be 4,800 plus n minus 1 times 250. N minus 1 times 250. Now let's distribute. S income is equal to n over 2 times, let's multiply this, 9,600 plus 250n minus 250. So this SI is equal to n over 2 times this minus this, 9,600 minus 250. Let's compute it here. 9,600 minus 250. This is equal to 9,350. 9,350 plus 250n. This is equal to, now let's divide this and this by 2. So we have n into 9,350 divided by 2. Let's divide. Is equal to, 9,350 divided by 2, which is equal to 4,675. 4,675 plus 250 divided by 2. 250 divided by 2, which is equal to 125n. 125n. Again, let's distribute n here. So this is equal to, this times n is 4,675. 4,675n plus this times n 125 n square. Now here this is the S income value, again S expenses here we have. Now let's join these two. So what we need to find here, after how many years will his expenses exceed his income? Expenses exceed, that means expenses is greater than his income. So let's take like this, S expense greater than SE greater or equals to, let's put it like this, SE greater or equals to SI. So from this, let's take SE here. Let's copy it here. Greater or equals to this one. $4,675n. Now let's collect like that. 200n square minus this. Let's subtract it. 200 minus 125 is equal to 75. 75n square. 75n square. Now let's subtract from this one. 2400 minus 4675 is equal to minus 2275 minus 2275 n greater or equals to 0. Now let's take common 75 here, 75n. n into n minus, let's divide this by 75. 2275 divided by 75, which is equal to okay 30 around let's take approximate value 30, which is equal to 0. So from this what you get, using product property, 75n is equal to 0. Let's divide by 75, so n is equal to 0 here, or n minus 30 is equal to 0. So from this what you get, n is equal to 30. So this is the answer. After 30 years, S expenses is greater, exceeds from S income. So we can read it here. We have the explanation here. We can read it here more. Okay, let's stop it here. So from this what you understand, let's remind it some the partial sum and arithmetic sequence. Arithmetic, so now this is an arithmetic series with common difference d. Again, in partial sum, you can compute the partial sum using this formula. Sn is equal to Sn, which is equal to n over 2, number of terms n over 2 times a1 plus an. What is a1? A1 is the first term, an is the nth term. So we can replace an by an, which is equal to a1 plus n minus 1 times d. N minus 1 product is d. Now let's replace this here. So Sn will be Sn is equal to n over 2 times a1 plus again a1 plus n minus 1 times d. This is the partial sum of the nth term, n minus 1 times d. This is the formula for nth term partial sum. Is the sum of the nth term partial sum. So again, or Sn means we can express like this. Sn is equal to a1 plus the first term plus the second term plus the third term plus up to nth term plus here an. This is the same with this one. This is all about today's topic. Thank you.